Hi, Hers. As promised, due to the feedback I was getting, I'm going to go over the past paper questions as a YouTube clip. Okay, so we'll go through it very, very quickly. I'll indicate the key points you need to be saying. Self-mark your work and be honest. Okay, if you got the answer wrong, yeah, who cares? The only thing I care about is if you do get the answer wrong, you learn from it. That's the main thing. Okay, right. Question 1. It would help if you have the questions to look at as well. Okay, because I do on my computer screen just now. So question 1, which of the following equation represents the first ionization energy of fluorine? The answer for that is C. Okay, C, you need to know your definition of first ionization energy. It's the energy required to remove 1 mole of electrons from 1 mole of atoms in the gaseous state. C is the only one that has atoms. Yeah, it can't be D. 1, that's not 1 mole, that's half a mole. And 2, that's a molecule, not an atom. Right, question 2. Now, with question 2 and question 3, it's talking about the attraction for bonding electrons. Okay, you need to know what that's talking about. It's talking about electronegativity. Remember, electronegativity, the definition of that is it's a measure of attraction an atom has for bonding or bonded electrons. Okay, so all you have to do for question 2, which of the following atoms has the least attraction for bonding electrons? If you turn to page 11 in the data book, actually I think I've got a data book here, just like that. If we turn to page 11, there's the electronegativity values on the side. Yeah, so all you really had to do was find out for question 2 which of the 4, carbon, nitrogen, phosphorus, silicon, had the lowest electronegativity. Okay, and that would have been silicon. Answer D. Question 3, which of the following atoms has the greatest attraction for bonding electrons? So you're looking for the atom with the highest electronegativity between sulfur, silicon, nitrogen and hydrogen, and that is nitrogen, C. Yeah. Question 4, using the information, what is the enthalpy change for the following reaction? Al plus going to Al3 plus 2 electrons. Now, the important thing, you've been given the first, second and third ionization energies. The important thing is that you need to recognise it starts on Al positive. Okay, so that means the first ionization energy, it's already happened. Yeah, the first ionization's already happened. So you don't need to include that value. So what you need to do is you add the second and third value together and you get a value of 4562, which is answer C. Okay, so C, D, C, C. Well done if you got those 4 right. Right, question 5. Explain why covalent radius decreases from the period from sodium to chlorine. Okay, if we look at sodium and chlorine, they're in the same period, so we talk about the protons. So as we go along the period, what do we add? A proton. Yeah, what does that proton do? It creates a stronger positive nuclear charge. What does that stronger positive nuclear charge do? It pulls the outer electrons closer to the nucleus, therefore the covalent radius decreases. Okay, so again, the important thing is we talk about our 3 P's. Yeah, protons added, stronger positive nuclear charge, and then that pulls the outer electrons. If you're not mentioning those 3 P's, you aren't going to get the maximum amount of marks. Right, question 5a II. Explain fully why the covalent radius of sodium is larger than the ionic radius of sodium. So you need to draw the electron arrangements out. Yeah. Now, the electron arrangement, the covalent radius of the atom is 281. Now, if that becomes an ion, it loses an electron to become 28. So we've got 28 and 281. So what does that mean? It means the atom, yeah, the sodium atom has 1 extra energy level. Yeah, be specific with your energy levels. So the sodium atom has 1 extra energy level. What does that mean? This extra energy level provides a shielding effect. What does that do? It weakens the force of attraction between nucleus and outer electrons, therefore the covalent radius is larger. Yeah, and that's it. Can be a tough question, but as long as you write the electron arrangement, you can't go wrong. Okay, right, B. Explain why the first ionization energy decreases going down group 1. So, what do we have? As we go down group 1, what do we add? An extra energy level is added each time. Yeah, and be specific. An extra energy level. What does that do? Provides a shielding effect. It weakens the force of attraction between nucleus and outer electrons. Now this is the important part. Because it's ionization energy, you remember a definition, it's the energy required to remove 1 mole of electrons from 1 mole of atoms in the gaseous state. You have to say whether it's easier or harder. So because it's further away and because there's a weaker force of attraction between the nucleus and outer electrons, it's easier to remove the outer electrons. So the first ionization energy decreases. Right, just going to cover up my camera so I can turn the page and cover up the answers. Yep. Right, where are we? 5bi. Explain fully why the second ionization energy is much greater than the first ionization energy of group 1 elements. Okay, so you'll notice if you look at the data booklet, all group 1 elements have 1 outer electron. Okay, so what does that mean? It means the second ionization energy of group 1 elements removes the electron from a stable shell / electron arrangement. Now I'm bringing in that word, a stable shell. Okay, you can say that, you can say electron arrangement, it doesn't really matter, but I'm going to start bringing in that term, a stable shell. So the second ionization energy of group 1 elements removes the electron from a stable shell / electron arrangement. Okay, now that would get you 1 mark. We need to say something else. Okay, the electron is closer to the nucleus where it is pulled more strongly by said nucleus. Okay, and you need to say that. You need to say that the electron's closer to the nucleus, and that means it's getting pulled more strongly by the nucleus. Okay, so well done. Obviously if I'm going too fast, you can pause it, whatever. Don't skip though, please make sure you're listening to the detailed answers. Question 6 was to skip. Question 7, name the element from the third period that exists as a covalent network. Silicon. There are only 3 elements, boron, carbon and silicon, and it's the 3 that hug aluminium. Okay, boron, carbon, silicon, they all surround, they all hug aluminium. Okay, so that's our 3 covalent networks. You need to know that, especially at higher. Right, 7bi, explain why the first ionization energy increases across the period. Okay, so as we go across the period, what do we add? A proton is added. What does that mean? It creates a stronger positive nuclear charge. What does that do? It pulls outer electrons closer to the nucleus, and because the electrons are closer to the nucleus, and we're talking about ionization energy, we need to mention that it is harder to remove the electron. Okay, and because it's harder to remove the electron, the first ionization energy increases. Okay, right, BII. Write an equation including the state symbols for the second ionization energy. Okay, so the first ionization energy takes us from an atom to a positive charge. So we start with a positive charge, yeah, and then what happens? that goes to an Mg2 positive, and we've removed an electron. Okay, so the important thing is make sure you get the charges right, and make sure you write the state symbols. See if you miss out those G's, you lose a mark. Okay, if you don't write the electron with the negative, you'll lose a mark. So please make sure you get all of that in. There, to be honest, there isn't actually an excuse for that, because if you look in your data book at page 11, at the very top, it gives you the first ionization energy. It also gives you the second. All you had to do was change the E to Mg. Okay, so that's it. Right, question 3. I like these questions, they always come up. Explain why there's a large difference between the third and fourth ionization energies. If I draw that out, yeah, there's the third, there's the fourth. The third, Mg2 plus to Mg3 plus, and then the fourth is Mg3 plus to Mg4 plus. What we notice is that here we've got a stable electron arrangement. So the fourth ionization energy is taking an electron from a stable arrangement or a stable shell. Okay, so the fourth ionization energy of magnesium removes an electron from a stable shell / electron arrangement. Okay, next point, the electron is also closer to the nucleus. What does that mean? It's pulled more strongly by the nucleus. Okay. Oop, just I'll cover up. Right, C we were to skip. Right, question 8. Going down group 7, the electronegativity of the halogens decreases. State what is meant by the term electronegativity. Yeah, you need to know it. Just memorise it. It's a measure of attraction an atom has for bonded electrons. Now, that's easy. That's easier in homologous series. That's easier in isomers. Okay, just make sure you learn it. Question 2. Explain why electronegativity values decrease going down group 7. Okay, so as we go down group 7, what do we add? An extra energy level. Okay, and again, be specific, an extra energy level is added each time. Okay, what does that mean? It means the extra inner energy levels, that provides a shielding effect. What does the shielding effect do? It weakens the force of attraction between nucleus and outer electrons, therefore electronegativity decreases. That's it. Okay. B we were to skip, and question 9. Explain the decrease in atom size going across the third period from sodium to argon. Okay, so as we go along the period, as we're going from sodium to argon, what we're adding, a proton is added. Yeah, what does that proton do? It creates a stronger positive nuclear charge. What does that positive nuclear charge do? It pulls the outer electrons closer to the nucleus, therefore atomic size decreases. Okay. If during this sort of homework, classwork, whatever, you feel like you were writing the same thing over and over and over again, it's because you are. Okay. You're only changing it ever so slightly. If the question asks about electronegativity, you're writing electronegativity decreases. If it's talking about atomic size, you're writing atomic size decreases or increases. The only one that's different is ionization energy, where you need to mention whether it's easier or harder to remove the electron. Okay, these questions are less creative. They aren't very imaginative. They aren't very imaginative with these questions. Yeah, it's the same ones that come up year in, year out. You just need to know how to answer it. Right, question 10A. Explain why the first ionization energy shows an increase going from neon to from lithium to neon. Now, if we look at our periodic table, we'll see that lithium is there and neon is over there. So you'll notice they're in the same period, okay? So, if they're in the same period, if I'm just going to show you the answer, as we go from lithium to neon, a proton is added each time. Yeah, this creates a stronger positive nuclear charge. What does that do? Pulls out the electrons closer to the nucleus, and because it's ionization energy, because they're closer to the nucleus, it's harder to remove the electrons. Therefore, first ionization energy increases. Simple. Simple. Right, where are we? 10A. Explain why the first ionization energy of potassium is less than the first ionization energy of lithium. So what I've done, just at the top here, oh, I don't think you can see that. Right, hopefully this doesn't mess up my phone. Basically what I've done at the top there is I've put in the electron arrangements for each one. So potassium 281, lithium 21. Okay, so just bear that in mind. So you need to mention that. So potassium has two So potassium has two extra energy levels. Yeah. So the extra inner energy levels provide a shielding effect. What does that do? Weakens the force of attraction between nucleus and outer electrons. And remember, we're talking about ionization energy, so because they're further away, because the force of attraction is weaker, it's easier to remove the electron. Okay, so the first ionization energy of potassium is less than that of sodium, or lithium, sorry. Oh, sorry, I've put, I've put sodium there, that should be lithium. Just a wee deliberate mistake to make sure you're all paying attention. Right, B, I, what are we on? 10BI, we're almost there, Right, graph showing the ionization energies for nitrogen is shown. Okay, so write the equation for the second ionization energy of nitrogen. So again, the first ionization's already happened, so we're starting Na plus going to N2 plus plus E minus. So N plus going to N2 plus plus E minus. And remember your state symbols. You missed them, you missed the mark. Okay. BII, explain fully the increase between the fifth and sixth ionization energy. So you'll see if you're looking at the questions, it goes up quite steadily, and then between the fifth and sixth one, it goes up massively. Why is that? Okay, so to show you, here we are. Okay, so the fifth ionization energy has an electron arrangement N4 plus has an electron arrangement 2-1. So the fifth ionization energy takes it to N5 plus, which is 2. Now you'll notice that 2 is stable. Yeah, it's got the same electron arrangement as helium, so it's stable. If we try and remove another electron in the sixth one, we're removing from a stable electron arrangement / stable shell. Okay, and then the next part, guys, you know this by now, these questions come up year in, year out. So the sixth ionization energy of nitrogen removes electron from stable shell / electron arrangement, and the electron is removed from a shell that's closer to the nucleus, where it's pulled more strongly by the nucleus. Okay? Right, C. Well, this is the last question. Sweet. Right, ionic radius is a measure of the size of an atom. Explain fully why the ionic radius of phosphorus is greater than the ionic radius of aluminium. Now, I looked at a few of your answers that sent me in the work so far, and majority are absolutely perfect. I think a couple of you made a wee silly mistake, but don't worry about that. Now, because it's ionic radius, Okay, because it's ionic radius, you have to draw the electron arrangements of the ions. Okay, now for phosphorus, the atom is 285. For aluminium, the atom is 283. Now, if that becomes an ion, remember what an ion has to be stable. So it has to have an electron arrangement either 2, 28 or 288. Okay, so phosphorus, it would gain 3 electrons to become 288. Yeah, and that becomes P3 minus. Okay, aluminium would lose 3 electrons to become 2,8. Okay, so remember when you're doing ions, you need to make sure the electron arrangements are stable for the ions. Okay. Now, once you've got there, it's so easy. Okay. What do you notice? Phosphorus has more energy levels. How many more? 1. So we say that. Okay. So I'm just going to show you the answer now actually. So P3 minus has 1 extra energy level. Okay, the extra energy level provides a shielding effect. What does that do? It weakens the force of attraction between nucleus and outer electrons. Therefore, the ionic radius is greater. Simple. Yeah. And then question 11 we were to skip. Right guys, that's us. I am happy that I feel comfortable with where we are with trends, just with seeing all the work coming in. You all have a great understanding of it. There's only a few silly wee mistakes that we tweak as we go on. Okay, the more sort of questions that we do, the better we become. Okay, what we're going to do now is, like I said in the post, it's my favourite topic, is enthalpy of combustion. Okay, I'm not going to start the higher side to that until next week. However, I do want to just very quickly revisit the National 5 side to it. So you should know from National 5 that equation E equals Cm delta T. So delta T is the change in temperature. M is the mass. Now this is where people always kind of went wrong. It's the mass of water. Okay. In fact, it is in kilograms. Okay. It's the mass of water or whatever you are. In fact, you know what? No, leave it there. It's the mass of water. Okay, and then C is the specific heat capacity. Okay, and if it's water, it had a very special number. You should know it, tattooed on your arm somewhere. 4.18. Okay, so remember, just a couple wee things. If it's 100 centimetre cubed of water, that translates, we need to divide by 1,000 to get into kilograms. That translates to 0.1 kilogram of water. Okay, so make sure you understand that. You're going to be doing some today. You're going to be doing some work on this. It will just be National 5. It'll be National 5 solely, and then that'll be us. I don't want to rush it, obviously. Remember, if we want to find out C, we take the EH and we put everything else on the bottom. Not that you would ever want to find out C, but say you did. If you wanted to find out M, it's the same idea. Put EH on the top and then everything else on the bottom. If you wanted to find out delta T, put EH on the top and then everything else on the bottom. Okay, in National 5 we also, if if you were in my class. Anyway, we did a sort of triangle. Okay, and then whatever one you wanted to find out, you cover up. So if we wanted to find out EH, cover up EH, so that's C times M times delta T. If we wanted to find out delta T, that is EH over CM. If we wanted to find out M, that is EH divided by C times delta T. So whatever method you use, make sure you're comfortable with that. Okay, now just remember, that's the important part. M is the mass of water, not alcohol burned, not the alkene that's burned, it's the mass of water. Right, that's us.